Happy New Year! Hope you are well. Sorry I didn't upload for so long, so I'm making a new video in the new year for my channel. Today, the topic is the Euclidean algorithm. Now firstly, what is an algorithm? An algorithm is a step-by-step procedure which helps you to solve a problem. If you perform one step, then you get a little bit closer to solving the problem. If you do another step, then you get even closer to solving your problem, and so on. For example, when getting ready to school, there are many steps. Firstly, you wake up. Then you brush your teeth. Then you eat breakfast. Then you get your bag ready. Then you take a bath. And then you have to take your bag and then get on the bus. And finally, you go to school. So we can see there are many steps. Similarly, in math, algorithms are the same thing. However, instead of being real-life actions, they are performed with numbers, or in some cases, variables. Euclidean algorithm is one of the oldest algorithms. It's an algorithm for finding the HCF or GCD of a number. The full form is highest common factor. A common factor is a number which divides two other numbers perfectly without leaving a single remainder. For example, let's take our two numbers to be 8 and 4. We can obviously see that 2 divides them with the remainder as 0. For example, 4 divided by 2 is 2 and 8 divided by 2 is 4. However, 3 is not a common factor because, as we can see, 4 divided by 3 is 1 with a remainder of 1. So 3 is in fact a factor of all of the numbers. In fact, it's a factor of none of them. However, 2 is not the highest common factor. The highest common factor of two numbers is the number which divides both of them like a common factor and is the highest number or the largest number which can do that. For example, the HCF of 8 and 4 is actually 4 because 4 is larger than 2 and it still divides both 8 and 4 perfectly, because 8 divided by 4 is 2 and 4 divided by 4 is 1. Again, 0 remainder. In this video, I'll present the Euclidean algorithm, which is the method. Now let's say we have two numbers, but we want to find the HCF of. For example, 144 and 262. Now, the first step is to subtract the smaller number from the bigger one. For example, 262 minus 144, which evaluates to 118. Now, we take this difference and the previous number as the new pair. For example, 114 and 118. Now, we make this a new pair and we repeat the process. For example, here, 144 minus 118, because 118 is smaller than 144. Here, we get 26. Now here, you might realize a problem. If you subtract 26 once away from 118, then the remainder is much larger than 26. So instead of doing that, we subtract 26 away from this number multiple times, enough so that the remainder becomes less than 26. For example, we can subtract once and then we get 92. Now 92 is way bigger than 26, So we repeat. Now we have 66, but it's still bigger. So we repeat again, and we continue doing this until finally we get 14, which is indeed smaller than 26. Most of the time, however, we do not do this all the way. Instead, we can say that 26 fits into 118 4 times. So what we do is we multiply 26 by 4. So 26 times 4 is 104. Then we do the subtraction. You can see that these two numbers are the same. This method is a lot faster, so I'd recommend you use this one. However, if you're confused, you can still subtract the numbers one by one. And after that, it is just the same until we get to the point where one of the numbers equals 0. When this happens, obviously, no matter how many times you subtract 0 from a number, it's gonna be exactly the same. So when there's a 0 here, we just pretend that the 0 does not exist, and look, we have 2, and 2 is our HCF. Therefore, the HCF of 144 and 266 is 2. You can see that in this case, the two numbers had an HCF that is larger than 1. Why is that important? Because 1 is a common factor of every number. So, when two numbers have an HCF of 1, the highest common factor they have is 1. That means that they are co-prime, because no other number apart from 1 will fit into both of them perfectly. An example of two co-prime numbers is 28 and 39. Here we can repeat our process until we get to this point. Here. Now we can see that there's a 1 in the pair. Now we continue our step. But the next step, when we multiply 1 by 5, you can see that we have a 1 and a 0. So if we cross out the 0, then we have 1 as the HCF. Therefore, 28 and 39 have an HCF of 1. Now, this works all the time. But why does it? For that, we're going to prove this formula, that this formula always works, the algorithm. So let's say we have two numbers, A and B. These are variables. Now, A and B have some highest common factor, which we will call F. Therefore, A can equal to CF and B can equal to DF. Remember, these are all variables. A or B or C or D or F can be any number you like. It can be 1, it can be 2, it can be 77. They just have to be whole numbers, natural numbers. However, here, now we're going to just replace it with CF and DF. Now let us always assume that B, or in this case DF, is the smaller one. Of course, sometimes A is smaller than B, but in that case we can simply swap A and B around and we have B being the smaller one again. That means that we can have CF minus DF. Sometimes you're going to have to subtract more than once, and that's perfectly okay. Just repeat it until CF minus however many times you subtract df, is lesser than df. We are going to represent it as cf minus n times df, where n is just an arbitrary number that depends on all the others. Now, you can notice that there's a common f, so we can factor it out, minus d minus n df. So, this is still a number times f. And at the other side, we have df. So, these still have a common factor of f, the highest common factor, since we said that f was the highest common factor. And since the numbers go smaller, there is no way that the highest common factor can get bigger. However, look here. If we take cf and df, we also see that they have the same common factor, f. So we can see that the common factor stays the same. So if we repeat this, the highest common factor stays the same. That is until we get to the point where we have 0 and another number, which is, let's say, e. In this case, they both don't have a highest common factor. Actually, they do, and that highest common factor is e, for obvious reasons. Here, 0 times any number is, well, 0. So technically, any number is a factor of 0. And e, the highest common factor, well, the highest factor in this case, is e itself. So e is the highest factor. But notice, the highest common factor never changes throughout this process. So we should end up with the highest common factor being f. So e equals f. So we have 0 and f, the highest common factor. Therefore, we have proof that f is the highest common factor and it ends up here. So this method always works and we have finished the proof. That is the video over. Bye bye, and I hope you have a wonderful new year.